let's dive straight into what an LLM is. LLM stands for Large Language Model, and it is basically the brain for every generative AI. You can find more about this in this website over here, which I'll place in the description for the video. Basically, you can learn everything about what an LLM is by just pressing the spacebar. So as I press the spacebar, it explains to me, welcome to the walkthrough of the GPT large language model. Here we explore the model Nano GPT with mere 85,000 parameters. Then it goes on explaining how it will order the inputs. So the input starts with CBABBC. Then first of all, it finds each token, sends that over to an embedding. After the embedding, it sends them all over to the transformers, at which is this entire scope over here. So don't bother with the technical aspects of how to build an LLM, because that's not what we're going after here. That is more of a duty for the ML engineer. What we're aiming at is the AI engineer. The AI engineer basically gets the LLM model already done and uses it for many different purposes. So through this list, I've gathered everything I believe you need to know to effectively use these LLMs. Starting off with the window context, this is related to how much space we have to actually work with the LLM. To keep it short, what LLMs actually do are predictions based on training. At the very beginning of the training, we start off with raw data. And then we need to transform this into an actual data set. This data set is a structured way to represent all that raw data. This way we can create a standard for the training of the LLM. With that said, let's look at some LLM metrics, starting off with the context window. A context window is basically how much context you can hold along a conversation with LLM. Normally the context window is measured by tokens, but let's say that the context window for a specific LLM holds 5,000 words. If it holds only that much, and only in your input you send over 6,000 words, you'll probably get an alert saying you can't do this because it doesn't accept that amount of context. Now, this is pretty much self-explanatory because you understand that along your conversation with a chatbot, you send an input, then you receive an output, and this is all measured by the input and output over here. But the longer this context window grows, we end up depending on two factors. So either the company holding that LLM has pretty nice hardware to back that up and process a lot of data, or the LLM has a pretty awesome algorithm to work with all the context it has, so it correctly understands how it should fetch for specific data. The example of a company that has a pretty nice algorithm is Anthropic. So the model, let's say Claude 3.7, it has a pretty good understanding of its context. Even if you have a really large conversation with it, it'll understand even one of the first things that you talked with it earlier. When you ever see the latency metric, it's basically telling you how much time will it take for the provider, let's say OpenAI, to send over the very first token that you'll be able to access to in your own application. So you'll have your application running right over here. As soon as you make a request, how much time will it take for OpenAI to send back the request? And this will probably be measured in milliseconds. So if you receive something like 100 ms, that means that it's taking 100 milliseconds for OpenAI to send you the first token response. Now, in some cases, you want to stream some responses. You know, when you send over a message to OpenAI, so let's say this is ChatGPT, and then you send over, let's place this in green for our input. So my input, and then it outputs something like this, then it continues typing. And it really feels like it's typing back to you. That is what we call streaming. So as it's analyzing the probability of the next token to use, it's already finding that token and sending back to the context of the conversation. The throughput is basically the calculation between how much time is it taking for each token to be processed and sent over to your chat. So if in here you get a response like 1,000 ms, then that means each token is taking 1 entire second to be sent back. So it's probably not a good LLM. LLMs have a maximum output metric, which basically measures how much tokens can they process as an output. It doesn't really cover the entire window context, and it's important for it to have this maximum output because then it always considers that it has the input and then how much of space does it have left to generate that output. Now, as soon as you get your LLM up and running, you'll want to check for the metrics on that LLM that you're using, and you can see that through your providers. So inside of OpenAI, this is how I can check how much I have spent for this default project in the past days. For this time frame, I've spent around 65,000 total tokens. And also for OpenRouter, which is another way to access these providers, you can check how much you've spent with each different models through this panel over here. And OpenRouter is a pretty cool tool to check out because you can use a lot of different models. You can see that I've used Claude 3 Opus for some reason, Gemini 2.0 Flash, and yeah, you can use OpenAI's model all inside of OpenRouter. So you can get everything organized just inside of this specific panel. But the problem with this approach is that you're quite limited to the information that you get back. I'll hit play just for you guys to get a preview of what they actually do.
On the LangFuse dashboard, you can see all important metrics to monitor your LLM application. This includes overall volume, usage by model or token types, cost breakdowns by user, latency distributions, and quality metrics. Tracing is at the very core of LangFuse. When we interact with this example application, which is available in our documentation, by asking questions about LangFuse,
and then he proceeds on to showing an example and showing how to track each one of the interactions with the LLM. So it's pretty interesting. For the first tools you'll be building, you really won't need to use this. You'll only need to use this like operating at scale, to be honest. But it's pretty important for you to have the knowledge that this exists and that you should at some point get to use these kind of tools. As for the LLM overall metrics that I've noted down here, it's basically about how are you going to retrieve all the metrics from a specific LLM. I would recommend using OpenRouter again, because as I typed in here Claude 3.7 Sonnet, you'll see that I have the entire context window. I have the idea of how much I can spend with output tokens and how it compares with different LLMs. So down here, you'll see that I have Google Vertex, which has the same amount of context, its max output, input, output, latency, throughput, and so on. There's a huge battle between providers such as Google, Anthropic, OpenAI, Grok to see which LLM is actually the best. But fortunately, we have a leaderboard for that, and that is the lmarena.ai. Over here, you can check which are the ranking LLMs based on tests between different LLMs. So over at this tab where it says Arena Battle, you can type in something here like describe a ball. And then Model A, which you don't know which model this is, will battle against Model B. And then depending on the response, you will vote on either Model B or Model A, and then that is computed and sent over to the leaderboard. So that's how we get these scores over here. And currently, for the moment, Gemini 2.5 Pro experience from March 25 is actually the best LLM, at least for the Arena score. Another rank I like to use is also from OpenRouter, and you can notice that Anthropic Claude 3.7 has been the most used. This doesn't really identify it as being the best model. It just says that it's one of the most used models. And I understand why this is actually one of the most used models, because as I mentioned earlier about the context window, if it correctly understands, like if it's more reliable based on the context given, then it is more predictable to use, and companies will prefer to use a more predictable model where you understand like its output and doesn't increase how random it is as more tokens comes in. Now let's go over to the API calls. I've already noted down here that the frequency penalty is to avoid repetitive words, as well as the presence penalty is to avoid repetitive topics. And you can find these parameters even inside of NAN. So these are all the parameters that you can send over to the AI. Normally people don't even toggle these, and you really don't have to, but sometimes for your specific prompting, you want it to not use so much repetitive words, or you don't want it to go so much off topic, and you can toggle that through these two parameters. Again, you can find them over here, so frequency penalty as well as presency penalty. And just remember, frequency penalty are to avoid repetitive words, and the presence penalty is to avoid repetitive topics. Now, as for sampling temperature as well as the top P, these are kind of hard to explain, so I have an example to use, which is whenever you type the AI Forge is, the next predictable sentence or the next predictable tokens could be either one of these. If you define a sampling temperature really high, that means I want it to be more creative and consider the possibility of using either one of these sentences. If I choose a top P of, let's say, 0.5, that means that out of all these possibilities, the ones that have the half the possibilities of actually making it through, which would probably be the world domination as well as a community, because we found 1,000 texts from the data set for a community to be predicted as the next tokens to use, as well as we found 800 texts for world dominations. So by specifying to the top P that I want just the 50% mark, then it will only accept from there on. And this is really a rough example. It's not exactly like, this isn't so simple, but below in the video, I'll give a better description that you might understand this. Overall, just go with the temperature. So every time you want it to be more creative, you'll want to use a higher temperature. If you want it to be more deterministic, just use a lower temperature. The max retries parameter is really intuitive. It's basically telling the AI agent how many times should this specific LLM be used. So as I make a question for this AI agent, how many times does it have to recursively use the OpenAI chat model to answer that question? The maximum number of tokens is pretty important because sometimes you just want to fetch through an API a single word, or you just want to fetch a sentence. So it really doesn't make sense for that API call to go above 500 tokens, for example. And this is where you can set it to not go past a certain mark. The response format is really important because you can either define it to return you a text. This is ideal for when you have a chatbot and you just want it to interact with the text, where it can identify if it's talking to a user, which messages it sent, and there's even one more topic here to talk about, with which are roles. In these roles, and let me skip just a bit here just to explain the roles, we have users and assistants. The assistants is any messages retrieved from the LLM, and user, actually it's not in plural, it's in the singular, because every time you see this, it's basically telling the LLM, hey, this was a message sent from the user, or this was a message that you sent back. And so the response format, when you set it to a text, it's basically informing the LLM, hey, you just need to output a specific text. But the other format we have is a JSON, and this is when you expect the LLM to return you a structured data. In a lot of the live builds, you'll see that I prefer to use a structured JSON, especially because most of the times I don't want the LLM to be responding back to the user. I just want the LLM to structure a data at which I'll use for another part of my code. And finally, we have the timeout. This is usually measured in milliseconds, and it just specifies to the LLM how much time should it just close down the connection until sending you back a response. Because sometimes you'll send an API request to OpenAI asking something, and if it goes beyond 1 minute, then that just says that there's an error there, and you don't want it to be continuously fetching, because maybe it's just better for it to close that specific request and start a new one, because probably it was a bug from OpenAI side or from your own side, and that can be detected if you correctly place a timeout.